I am Gate Handler, and like my friend Gate Willie, I am also highly impressed with Hinduism and its teaching. So I speak Jai Bajrangbali, Jai Sri Sitaram. Let's now talk about magnetic discs. A magnetic disc is a thin circular plate or platter of a metal or plastic. Its surfaces on both sides have coating of iron oxide that can record data by magnetization. Data is recorded on its coated surfaces as tiny, invisible, magnetized and non-magnetized spots representing digit 1 and digit 0. It uses a standard binary code, that is EBCDIC code, for recording data, which is a 8-bit code. The disk itself is stored in a specially designed protective envelope or cartridge, or several of them are stacked together in a sealed, contamination free container. Magnetic disks are the most popular direct access secondary storage device. They are also the most popular online secondary storage device. We can erase old data and record new data on magnetic disk as well. As we record new data on it, it erases old data in the same area automatically. However, we can read stored data many times without affecting it. Now let's talk about the storage organization of a magnetic device. Magnetic disk, not device. The magnetic disk surface has a number of invisible concentric circuits called tracks, and tracks have numbers consecutively from outermost to innermost, starting from 0. Number of tracks varies greatly, with low capacity disks having as few as 40 tracks and high capacity disks having several thousands of tracks. A magnetic disk surface also has invisible pie-shaped, pie-shaped segments. There are 8 such segments. Each track has 8 parts. Each such part of a track is called sector. Typically, a sector contains 512 bytes of data. It is the smallest unit of data accessed by a disk drive. That is, disk drives can access, read or write a complete sector at a time. Even if a computer needs to change just one byte out of 512 bytes stored on a sector, it rewrites the entire sector. When people refer to the number of sectors a disk has, the unit they use is sector per track, not just sectors. If a disk has 200 tracks, and 8 sectors per track. It will have 1600 sectors with each sectors having a unique number. Now to access a piece of data from a disk, we need to specify its disk address, which represents the physical location of the record on the disk. It is comprised of sector number, track number, and surface number. Often, multiple disks are stacked together as a disk pack to create large capacity disk storage system. The disk pack is sealed and mounted on a disk drive consisting of a motor to rotate the disk pack about its axis. The disk drive also has an assembly, access arms assembly having separate read and write heads for each recordable surface of the disk pack. Normally, a disk pack does not use the upper surface of the topmost disk and the lower surface of the bottommost disk because of these surfaces get scratched easily. In modern disk drives, use miniaturization and precision components to eliminate this drawback. All access arms of an access arm assembly for all disk surfaces move together. Hence, if the read-write head serving the zeroth recording surface is positioned over the sixth rack, each of the hits on the arm serving other recording surfaces is also positioned over the sixth track of respective surfaces. For faster access of data, disk packs use a concept called cylinder for data organization. A set of corresponding tracks on all recording surfaces of a disk pack together form a cylinder. Consider the fifth track of all recording surfaces together forms the fifth cylinder of the disk pack. Hence, if there are 200 tracks on each disk surface, there will be 200 cylinders in the disk pack. Obviously, disk address of a data record on a disk pack consists of sector number, cylinder number, and surface number. This addressing scheme is called cylinder head sector addressing. In short, it is written as CHS, that is cylinder head sector addressing. It is also known as disk geometry. Now, CHS based organization achieves faster access of data by avoiding movement of access arms when application has to process large number of records in a sequence. It stores related records of a file on the same cylinder of a disk pack so that in one revolution of the disk pack, the disk drive can read and write all records stored on said cylinder 5 of all surfaces. Now let's talk about the storage capacity of a magnetic disk. It is given by a formula, that is the storage capacity of a disk system equals number of recording surfaces multiplied by number of tracks per surface multiplied by number of sectors per track multiplied by number of bytes per sector. Now let us assume that a disk pack has the 10 displays that is 2655 tracks per plate and 125 sectors per track and 512 bytes per sector. Now its capacity will be given as 18 multiplied by 2655 multiplied by 125 multiplied by 512, which is approximately equal to the 3 into 10 to the power 9 bytes or 3 GB or 3 gigabytes. As one character is stored per byte using 8-bit EBCDIC encoding, the disk pack can store over 3 billion characters. For large storage capacitor, designers prefer to increase storage capacity by increasing the number of tracks per inch of surface and bits per inch of track rather than increasing disk size. Hence, a constant goal of designers of disk system is to increase the data density of each square inch of disk surface. Let speaks Jai Bajrangbali, Jai Hanuman, Jai Shri Ram, Jai Sita Ram, Jai Shri Ram, Jai Radheshyam, Om Namah Shivaya. Now let's talk about the access mechanism. A disk drive records data on the track of a spanning disk surface and reads data from the surface by using one or more read and write heads on its access arm assembly. Most disk drives use a single read and write head for each disk surface. However, some faster disk systems use multiple heads on each access arm to service a number of adjacent tracks simultaneously. As the access arm assembly moves in and out in the direction the read and write hands move horizontally across the surface of the disk. In this manner, the disk drive positions the read and write heads on any track on or from which it wants to record the data. In case of a disk pack, each usable surface has its own read and write head, and all heads move together. Hence, the disk drive can simultaneously access information stored on the tracks constituting a cylinder through the disk pack. Recall the cylindrical storage arrangement of the information in a disk pack. Read and write heads are of flying type. They do not have direct contact with disk surfaces. There is a separation of about 0.0002 inch between a read and write head and its corresponding disk surface. This prevents wear of a disk surface. However, read and write heads fly so close to disk surface that if a dust particle, typically of 0.001 per inch of size, or a smoke particles typically of the order of 0.0002 inch of size, or fingerprint typically of 0.00067 inch of size, or a human hair which size is typically of 0.003 inch is placed on the disk surface, it would bridge the gap between read and write head and disk surface, causing the heat to crash. A heat crash in which the heat touches the disk destroys the data stored in the area of the crash and can destroy a read and write head as well.